Alrighty guys, in case you wanted to know how my Monday morning was going, this is now the third time that I am trying to record this video. So I'm hoping that the third time is the charm. So this is your video for 2.3.2, which talks about the Pythagorean theorem. So like I said, we're going to take 2 days to develop the idea of the Pythagorean theorem, practice it, and understand it. So yesterday was day 1, even though we might not have called it that. We didn't really use those words at all. Yesterday was the first official day. You guys were figuring out the long way to use the Pythagorean theorem. So that's why this chapter, or this section, is literally called Is There a Shortcut? And it's called the Pythagorean theorem. Yes, there's a shortcut. It's called that. So if you guys remember yesterday during the video, we talked about this square, and we talked about how what you would do is you would take the side lengths here, and you'd add those up. You'd add, like if this was 7 and this was 2, like the video yesterday, this length would be 9. Then you'd find the area of the bigger square, which would be 81. And then you'd subtract the area of the 4 triangles from it to find the area of C, which is the Pythagorean theorem in disguise. Okay, so it's just the Pythagorean theorem disguised. So what we're going to do is we are going to show you how and why that works, and kind of understand the meaning behind it. Okay, so anytime we think of squaring something, you should literally think of the shape a square. That's why we call it squaring. It's a square. Okay. So you guys, when you guys come into class, you guys will do 2.1-9. We're going to talk about 2-110 together right now, and then you guys will do 211 and 12 in class, and then your exit ticket like always. So let's go ahead, and I want to show you a Desmos activity so you guys can actually see what's going on when we use the Pythagorean theorem. So the Pythagorean theorem states a squared plus b squared equals c squared. Okay? So what I want to do here is that let's just talk about the areas of these squares. So if you think about the area of this red square, it's going to be the length is b, the width is b, so the area is going to be b squared. The area of this multicolored square is going to be a squared based on the same principle, which means this big square is going to be, that's not what I wanted, c squared. So we are going to try and fit b squared and a squared into c squared to prove that they are actually equal to each other. So what I'm going to do is I'm just going to drag this over. And then I'm going to see if all of these triangles can fit into the square, which as you can see, they are doing. So essentially what happens is, and the reason we can use this formula is because when you take b and you take a, when you take b squared and a squared and you try and fit it into c squared, they all fit evenly. So that's why we can make this equation equal. They are the same. We're adding all of those squares together, and they are equal to c squared. There are tons and tons of proofs about the Pythagorean theorem. Actually, in one of my geometry classes in college, we all got a different proof for the Pythagorean theorem, and that was our final for the class. So kind of interesting to see all the different theorems and all the different proofs, but this is just one of them that you can see why it works and how it fits together. So going back to this, let's actually talk about the methods and meanings box, which is also in your book if you need it. Actually, before that, I do have a joke for you really quick. This one's not as good as the other ones, but it's okay. It'll be fine. Get it? He goes from 8 to infinity. Alrighty. So, methods and meaning. So the Pythagorean theorem, this just states, again, your hypotenuse is always the longest side. You will also be heard it talked about as the side across from your 90-degree angle too. So sometimes it can be kind of tricky to see which side's the longest. It's always the side across from 90 degrees is your hypotenuse. And then you got leg 1 and leg 2. So again, length of leg 1 squared plus the length of leg 2 squared is equal to the length of the hypotenuse squared. So not only can it be used to find the hypotenuse, which is what we were using it for yesterday, but it can also be used to find the missing side lengths. So this one is finding x. So we're sitting here, we say, hey, we're given the hypotenuse, but we're not given the other side, the other leg length. So let's find that. It doesn't matter which one's a and b. Okay, if you think about it, 4 plus 3 is still 7, 3 plus 4 is still 7. So it doesn't matter which one's the leg length. What does matter, though, is the hypotenuse. Remember, that's always the one across from the 90. It's always the longest side length. So they did 5 squared plus x squared equals 8 squared, and they simplified that to 25 plus x squared equals 64. They subtracted the 25 and got x squared equals 39, and then x equals radical 39, which is equal to 6.24. Again, in your head, does this make sense? Okay, this measure right here should be smaller than 8. If it is not, it does not make sense and something went wrong. Okay, so remember that those are the questions you need to be thinking to yourself in your head is doesn't make sense. Alrighty, for the review preview problems, I'm actually gonna go back to the book really quick. I think you guys understand systems of equations. This will be on your guys' team test. It'll also be on your individual test, so be ready for that. But based on the exit ticket and the homework quiz, I think you guys are pretty good on those. We will be doing 214 together, or 2-114 together, and then you guys will have 115, 116, and 117 to do on your exit ticket. Alrighty. Okay, so I already drew the shapes here for you. So Hannah's shape bucket contains an equilateral triangle, an isosceles right triangle, a regular hexagon, a non-isosceles trapezoid, a rhombus, a kite, a parallelogram, and a rectangle. If she reaches in and selects a shape at random, what is the probability that the shape will meet the descriptions based below? So at least 2 sides are congruent. So I'm just going to go through and circle the ones that have 2 sides that are congruent. 1, 2, 3, 4, 5, 6, 7. So 7 out of 8 of them have sides that are congruent. Alrighty. The next one says 2 pairs of parallel sides. So they need to have more than 1 parallel side. So 2 parallel sides. Alrighty. So for this one, when we are working with it, we know that the parallelogram has 2 sides that are parallel. We know that the rectangle has 2 sides that are parallel. And the rhombus has 2 pairs of parallel sides. If you guys still struggle with that, go to that shape toolkit I gave you guys. I think it was on purple paper. And go back and just review which ones are parallel and what have congruent sides and everything. So this is going to be 3 out of 8. And then the last one says at least 1 pair of parallel sides. Okay, so now we're just looking at 1 pair of parallel sides. So we got 1, 2, and then 3, 4, 5. So all the ones that we already starred for 2 pairs, and then you also have the quadrilateral, the non-isosceles trapezoid, and the hexagon have parallel sides as well. So that is going to get us 5/8. Alrighty, so much shorter video today. Your guys' team test is going to be on Wednesday, so make sure you guys are preparing for that. I will have a review video for you guys ready for you guys to watch, so you guys can review all the topics and the ideas that we covered in this lesson. Other than that, I hope you guys have a great night, and I will see you guys in class tomorrow.